Hey everyone, in this video we are going to be talking about density. So the first thing that we need to know is what exactly density is. So density is the measure of the mass in a given volume. Or another way of thinking about this is that it's the amount of stuff occupying a certain amount of space. And the reason why these definitions are kind of interchangeable is because the amount of stuff, that's going to be your mass. And a certain amount of space, that space is going to be your volume. And one thing that we need to note for later on, and you should have learned this a long time ago, but the volume of a cube. So the volume of a cube is going to be your length times width times height. So that's for a cube. You will need that later on. Okay? And then we need to know our density equation, or the way that we write density. So density is written as mass over volume, or the way that you're going to see it and the way that I write it is M over V. Same thing, mass over volume. We're just making it a little bit shorter. And then it is known as the Hart-Breker equation. And the reason why we say that it is the Hart-Breker equation is because M over V kind of looks like a heart, and then the divide sign, that is kind of like you're breaking the heart. So you are going to be doing division whenever you're using the density equation, as well as some multiplication. Now, there are several different units that you can use for your mass as well as for your volume. So that means that you're going to have different units for your density. So you could see grams per centimeter cubed, meaning that grams is your mass and centimeter cubed is your volume. You could see grams over milliliters. You could see kilograms over liters. You could see kilograms over meters cubed. These are some of the most popular ones that you're going to see. But again, as long as you have your mass and then you have your volume, that's what you are concerned with. The next thing is more of a practical sense of density, as well as graphing density. So that is our slope. And I know that you've heard of slope before, and we typically refer to slope as rise over run. With density, the slope of a line comparing volume and mass represents a substance's density. And you may be like, well, how can that be? Well, we're going to go through and we're going to look at this as an equation. And one thing that I want to note, anytime that you see a triangle, that represents change. So if I'm looking at slope, we just said that slope is rise over run. Well, if I am rising, that's going to be on my y-axis of the graph, right? I'm going up or down. So that's my change in the y-axis. My run is whenever I'm going across or I'm on the x-axis. So in my density, which is mass and volume, my mass is going to be on my y-axis and my volume is going to be on the x-axis. So my slope is basically going to be whatever the change in my mass is over my volume. And just so that you can see this in a practical sense, let's say this is my graph. So we just said that our volume, which is typically going to be in milliliters, is going to be on my x-axis, which means this is going to be my change in x. And what I mean in change in x is wherever my starting point and then my final point, that change in between that. Which means that I'm going to have my mass, which we typically use grams, on my y-axis. So this is my change in y. Now, that is more of a practical sense of density, and that's what you're going to see used in the lab as well as the graph. Another way that we can look at density is by solving density problems. So when we are solving density problems, we are first going to use the guess method. So remember, that's where you go through and you basically are analyzing the problem that you're given and picking out the information that you actually need and what you don't need. And then we're also going to use something called the density triangle. And if we go back and we look at our equation for density, we said it was the heartbreaker, and its density is mass over volume. Well, I can also solve for the mass, and I can solve for the volume. And what this density triangle does is it helps me figure out what my equations are going to look like. So you can see here, I'm just drawing a triangle, and then I'm basically putting 3 different areas in the triangle. So in the top, we're going to have mass. On the bottom, we're going to have density, and then volume. Okay? And then in between the density and the volume, we just want to put an X for multiplication. Okay? So, the way this works is you cover up whichever letter that you are solving for. So, for example, if I'm solving for D first, I would cover up D, and then I'm left with M. I see the line, and then V. Okay? If I'm solving for mass, I cover up mass, and then I have D, which is my density, and you can do a capital D or a lowercase d, either one will work, and then multiplied by V. And then the last one is for volume. If you cover up the volume, you're left with M over D. Okay? So again, that's how you use the density triangle. I'm showing you the density triangle because it's going to save you time instead of trying to derive these equations yourself. Okay? Now, we need to do a couple of examples. So our first example is going to be calculate the density of a liquid whose volume of 2.60 milliliters has a mass of 6.47 grams. Now, I will tell you that you will be told how many decimal places to round to. In this one, we're going to go to 2 decimal places. So the first thing that we need to do is figure out what exactly are we given in this equation. So the first thing that I see is this volume of 2.60 milliliters. So that means that my V equals 2.60 milliliters. And then my mass. So we have a mass of 6.47 grams. So M equals 6.47 grams. My unknown, or the thing that I'm trying to get to, is they tell me calculate the density. So that means that they want me to solve for the density. So this time, I'm going to use that heartbreaker equation, or if I scroll back up, my D equals M over V. And then I just plug and chug, meaning that I'm going to plug my given values into my equation and then chug out the answer. Now, I typically combine the substitute and solve together. So you would have D equals our 6.47 grams. And notice I am including the unit. That's because I have to have units whenever I am solving my problems. If I don't have units, then I don't know what you're talking about. Okay? And here, if we plug this into our calculator and we want 2 decimal places, we would get that our density equals 2.49 grams per milliliter. So that means for, again, grams per milliliter would be my unit. Okay, that one was pretty straightforward because we were just solving for the density. In this next one, okay, we are going to change it up a bit and solve for something else. So in this one, we're going to calculate the mass in grams of 1.15 milliliters of gold whose density is 19.32 grams per milliliter. And again, our first thing is to figure out, well, what are we given, or what have we been told? Well, we're told that we have 1.15 milliliters, and this is where units is really important, because if I see that milliliters, I need to know that milliliters is associated with the volume. And then I'm also told that we have a density of 19.32 grams per milliliter. So D equals 19.32 grams per milliliter. The unknown, or the thing that I'm trying to find, is going to be this calculate the mass. And they specifically tell me that that mass needs to be in grams. So M equals so many grams. So now my equation, if I go back up to my triangle, if I'm trying to find the mass, is going to be my density times my volume. And then if we plug in, we're going to have that this is going to be 19.32 grams per milliliter. And I'm writing this specifically this way because I want you to see that whenever you do this, your units of milliliters are going to cancel out. And what that means is you have one on the top, one on the bottom. They're basically zeroing out, or they are canceling each other out. So then whenever you multiply, you're going to get that your mass is 22.2, and then your unit is going to be grams. Okay, and the reason why it is grams is because that milliliters has canceled out. Now, this next problem, I want you to try on your own. So you, after I write it out, pause the video, figure out your given, your unknown, which equation you're going to use, and then plug and chug. So calculate the volume in milliliters of 12.5 grams of iron whose density is 7.87 grams per milliliter, and then round to 2 decimal places. So again, you pause the video, figure out your given unknown equation, and then substitute and solve. Now, I trust that you have done that, and so I'm just going to go through and work this out. So my mass is 12.5 grams. Our density is 7.87 grams per milliliter. Our unknown is our volume, and they tell us that it needs to be in milliliters. So our equation is going to be V equals M over D. We're going to substitute in, so we're going to have 12.5 grams over 7.87 grams per milliliter. And again, these grams are going to end up canceling out. And whenever that happens, you are then going to be left with milliliters. And so my final answer is going to be that my volume is 1.59 milliliters. And then the last thing that we need to talk about is the volume of an irregular solid. And so what we mean by this is if we have something that is not necessarily a cube, okay? And the way that we're going to figure out this volume is through water displacement. So the volume of an irregular solid can be determined by submerging, and if we mean submerge, we just mean that we're going to put it into water. So basically we're going to take whatever this irregular solid is, we're going to put it into some water. And what happens is that the object, that irregular solid, displaces a volume equal to the volume of the object. And so in a practical sense, what this looks like is, let's say this is my graduated cylinder. Okay, and let's say that we have our measurements on here. And I'm not trying to make these perfect, okay? So here is, again, my graduated cylinder. And then I'm going to have my water in here. So let's say my water is about right here. And we're going to say that right here, that my volume is 9.8 milliliters. Well, then I'm going to put a rock. So I've got this water already in my graduated cylinder. Now I'm going to add a rock. And I know that's not the most amazing rock in the world, but it works. So whenever I've done that, what's happened is my water level has now risen because I've put this rock in there. So my new volume, let's say it was 18.4 milliliters. Well, I'm going to try and figure out the volume of the rock. And so the way that I do that is I have to look at the volume of water, which is H2O, plus our sample, which is, in this case, is the rock, minus our volume of H2O, which really means that we're looking at our final minus our initial reading of the water. So in this case, our final was 18.4 milliliters, and then our initial was 9.8 milliliters, which means that our final is 8.6 milliliters. And again, the biggest thing that you need to know for this is that you're going to have your water already in your graduated cylinder. You're going to put some object into the water. Your water level rises. So to figure out whatever the volume of that object is, you take your final water reading minus your initial water reading. And that is it for our density notes.